Welcome to Azure Simplified. In this section, we are going to learn about how to design a data storage solution for relational data. Table of Contents 1. Design protection for data, security for data at rest, in transmission, and in use. 2. Design for Azure SQL Edge, features, deployment options, and security. 3. Design for Azure Cosmos DB, overview, table API, and migration from table storage. Design security for data at rest, data in motion, and data in use. Organizations using Azure SQL database for sensitive customer data need security solutions to prevent unauthorized access. Classifying data by sensitivity helps assess risks. Effective security relies on data discovery, classification, and protection, with encryption playing a key role. There are three basic tenets of good information security: data discovery, classification, and protection. Data encryption for structured data. Data exists in three basic states: data at rest, data in motion, and data in process. Data at rest is data on a storage device that isn't being moved or used. Data at rest includes archived email messages stored in your Outlook inbox, or files on your laptop that you aren't using. Data in motion, also called data in transit, is data that's being moved from one device to another within a private network or public network like the internet. Data in motion can also be data that's being read, used, but not changed. Data in motion includes email messages in transit, browsing internet websites, or using company applications like an organization chart. Data in process is data that's open and being changed. Data in process includes writing an email message, saving your work files, or ordering from a website. Different encryption methods are used for each data state. Data at rest uses transparent data encryption, TDE, and is always encrypted. Data in motion uses SSL, TLS, and is always encrypted. Data in process uses dynamic data masking, where specific data is unencrypted while the rest remains encrypted. Data encryption at rest is essential for data privacy, compliance, and sovereignty. Protects against unauthorized access to raw files, backups, and offline threads. Prevents copying of databases and transaction log files to unsecured servers. Transparent data encryption, TDE, protects Azure SQL database, Azure SQL managed instance, and Azure Synapse Analytics from malicious offline threats. Encrypts data at rest in real time, including databases, backups, and transaction log files. No application changes required for encryption and decryption. Enabled by default for new Azure SQL databases and Azure SQL managed instance since February 2019. Example: implementing TDE for data at rest, Tailwind Traders. Scenario: Tailwind Traders, an e-commerce company, wants to secure its customer database stored in Azure SQL database. They implement transparent data encryption, TDE, to protect data at rest. How TDE works in this case? 1. Encryption at page level. A customer places an order, and their data, e.g., name, address, payment details, is stored in the database. SQL Server stores this data in pages, small storage units, typically 8 kilobytes. When the data is written to disk, TDE encrypts these pages automatically. 2. Decryption when accessing data. When a customer service representative queries the database for order details, the encrypted pages are read into memory and decrypted on the fly. The application sees the decrypted data, but the stored data on disk remains encrypted. 3. Database backups are encrypted. If Tailwind Traders creates a backup of the database, the encrypted pages are copied directly, no decryption occurs. This ensures that even if an attacker gains access to the backup file, they cannot read the data without the encryption key. 4. TDE in an always-on availability group, e.g., Tailwind Traders uses high availability by hosting database copies across multiple servers. Since TDE is enabled, the encryption certificate must be backed up and restored on all servers hosting the database copies. This ensures that all database replicas remain encrypted and accessible. Key points about data in motion and SSL, TLS. Azure SQL database, managed instance, and Synapse Analytics enforce SSL, TLS encryption for all connections. Ensures data in transit between client and server is always encrypted. Microsoft-supported drivers use TLS for secure database connections. VPNs can be used to further isolate communication between on-premises and cloud infrastructures. Example: protecting data in motion, Tailwind Traders. Scenario 1. Secure access from multiple on-premises workstations to an Azure virtual network. Example: the IT team at Tailwind Traders needs to provide secure access to their Azure hosted database for multiple employees working in the on-premises office. Solution: They use a site-to-site VPN, which creates a secure, encrypted tunnel between the company's on-premises network and Azure Virtual Network. Data in use and dynamic data masking. Data in use encryption protects sensitive information while it is being accessed or processed. Dynamic data masking, DDM, hides sensitive data in query results without altering the actual database. Example: customer assistants at Tailwind Traders only need to see the last 4 digits of a phone number for verification, while the rest of the data remains masked. DDM allows organizations to control how much data is revealed, reducing unauthorized access with minimal impact on applications. Azure SQL Edge. Azure SQL Edge is a lightweight database engine optimized for IoT and IoT Edge deployments. Built on the same engine as SQL Server and Azure SQL, allowing developers to reuse SQL Server code. Supports streaming, processing, and analyzing both relational and non-relational data. Azure SQL Edge in a relational data storage solution. Deployment and architecture. Azure SQL Edge is a containerized Linux application with a lightweight startup memory, less than 500 megabytes. Designed for IoT and edge computing, running on IoT devices, edge gateways, and edge servers. Built-in streaming engine enables data transformation, aggregation, anomaly detection, and classification. Time series storage allows indexing and aggregation for future cloud analysis. Interacts with edge components like gateways, IoT devices, and edge servers. Available in 2 editions with identical features but different memory and call limits. Deployment security in Azure SQL Edge. Azure SQL Edge inherits enterprise-grade security from SQL Server, ensuring a secure deployment from cloud to edge. 4 key security steps: platform and AMP, system security, protects the Docker host, OS, and network connecting IoT devices. Authentication and AMP, authorization, uses SQL authentication, username and AMP, password, and user permissions for access control. Database object security, protects database objects with encryption methods like transparent data encryption, TDE, and always encrypted for compliance. Application security, encourages secure coding practices for client applications. With these measures, Azure SQL Edge ensures robust security for IoT and edge deployments. Azure SQL Edge deployment options. Azure SQL Edge offers 2 deployment options: connected deployment, available on Azure Marketplace and deployable as a module for Azure IoT Edge. Disconnected deployment, uses Azure SQL Edge container images from Docker Hub, deployable as a standalone Docker container or on a Kubernetes cluster. These options provide flexibility for both cloud-connected and offline IoT environments. Azure Cosmos DB is a fully managed NoSQL database designed for modern app development. It eliminates database administration tasks by handling automatic updates, patching, and capacity management. Key benefits: serverless and AMP, auto-scaling, adjusts capacity based on demand. Fully managed, no need for manual administration. Ideal for scalable and cost-effective relational table data storage. Key considerations for using Azure Cosmos DB Table API. If migrating from Azure Table Storage, the Azure Cosmos DB Table API offers several advantages. Latency, provides single-digit millisecond reads, writes with guaranteed performance. Throughput, highly scalable, supporting greater than 10 million operations per second per table in provision throughput mode. Global distribution, supports 1 to 30 plus regions with turnkey global distribution. Indexing, automatic indexing on all properties, no need for manual index management. Query performance, uses automatic indexing for faster query execution. Consistency levels, offers 5 consistency levels to balance latency, throughput, and consistency. Pricing model, supports both consumption-based and provision capacity pricing. Service level agreements, SLAs, 99.999% RED availability for multi-region setups, with 99.99% availability SLA for all accounts. Thank you for watching. Please share an AMP, subscribe and comment your feedback.